Hi everyone, welcome to the presentation of this lecture on the hyperbola. So the equation of the hyperbola with the center at the origin and the horizontal and vertical axis of symmetry is very similar to the equation of an ellipse. Okay, so the hyperbola is basically a set of the points in the plane whose distances from two fixed points, which are the foci f1 and f2, they have a common difference. So it's plotted like so. So you have the x-axis and you have the y-axis there. So you draw this rectangle and two the lines passing through the diagonals, and these lines are called asymptotes. So this distance from this point to that point there, we are calling this one as our A, and the distance from this point to that point, we are calling it B. Therefore, this line from there to there, it's 2B, and the line from there to there, it's 2A. Once you have that, the equation of the asymptote for a hyperbola, which is in this form, because they are in two forms. One is formed along the y-axis and the other one along the x-axis. So for the one which is forming along the y-axis, the equation of the asymptote is y is equal to b over ax, whereas the other one will be negative because the gradient this side is negative. And then the equation of such a hyperbola is given by x squared over a squared minus y squared over b squared. So this is the general equation of the hyperbola. So if you see the hyperbola, because as you can see, there is x squared over a squared and y squared over b squared. When there are numbers here, how do you tell which one is a and which one is b? So the one which is on the negative side will be b, and the one which is on the positive side will be a, and that is telling you that such a hyperbola is forming along the x-axis. So you are going to have an hyperbola which looks like that. So the second case is this one, where you have your y-axis there and you have your x-axis. You draw that box, that being a value for b, and this one being the value for a. So for this one, you have your asymptotes like that. As you can see, it has changed now. For the one forming along the x-axis, it is y is equal to b over ax. The one forming in the y-axis, the asymptote is y is equal to a over bx. Once you have that, you have those your asymptotes, and then it will form like that. So for this one, the equation is that, as you can see the difference here, the one which is on the negative side, it is the x. The one which is positive is the y, and it's telling you that you are forming in the y-axis. So for the hyperbola, just look for the one which is positive. Then that is where your hyperbola will be drawn. If the positive one is x, then it will be in the x. If it is y, then it will be in the y, as shown like that. Then you have a focus. The focus is basically that c squared is equal to a squared plus b squared, which is, those are the points forming the focus. You have this one there. For the one in the y-axis, you have those. Okay, and those are their coordinates. For the one in the x-axis, in the y-axis, you have 0, c. In that one, 0, negative c. There it's negative c, 0, and the other one there is c, 0. So this one, I'm just telling you where it will form, to either be in the x or y-axis, depending on which one is positive. If the x squared is positive, then it's forming in the x. If the y squared is positive, then it's forming in the y. So let's look at the examples. Example number 1 is saying, find the foci, vertices, and asymptotes of the following hyperbolas and sketch the graph. So we have A, which is this one. This is our A, and we've got our B, which is this one there. Then we've got the second one, which is saying find the foci and the equations of the hyperbola with the vertices, which are those. So let's look at the solutions. For the first one, which is A, that's the equation which has been given. Writing it in standard form, we have that. So from this, of course, we have a clue. The y squared is the one which is positive. Therefore, the denominator is the A. And we know that the hyperbola of this form forms in the y-axis. Then B automatically will be that. So for the hyperbola that to calculate the focus, we are going to have that. We know it's forming in the y-axis. We're going to have a hyperbola, which is that. Just put in the values you've calculated there. Then the second one, we have that as the equation. putting it in standard form, we divide throughout by 144, and then it will simplify to that. So 9 divided by 144, you're going to have this 1 over 16. 16 divided by 144, you're going to have 1 over 9. 144 divided by 144, you're going to have 1. Once we have that, putting it in standard form, we are having this. We know the x squared is the one which is positive. Therefore, the denominator for x is the one which is a. So our a is 4, y is b, is 3, which is that one. And we know this hyperbola forms in the x-axis. So we have your a, which is this one, and our b is going to be that. The focus calculating is giving us that. Therefore, you're going to have the hyperbola which forms like that. Just putting the correct values there. Then number 2, find the foci and the equations of the hyperbola with those vertices. So the vertices themselves are telling us where it's forming. So it's 0, 1 or plus 1. So this is forming in the y-axis, because the x-coordinate for anything in the y-axis is 0. So we already know that. And from the asymptotes, we can easily calculate the values of a and b. So from there, those are the vertices. You have your y, which is that one. Y is equal to plus or minus that. From there, we know it's forming in the y-axis. So this is the equation, a over b. So we know our a is 2, b is 1. Once we have those, we have the focus, which is that one. And then it's very easy to graph it. You have something which looks like that. Of course, just put in the calculated values there. So this marks the equation will come out like that. So from there, just substitute the values. You're having that, which is basically that as our equation. So this marks the end of my presentation on the hyperbola. Thank you.